Welcome to Cooke State Park. Today it's a beautiful and popular place to hike and to enjoy nature. About 1.8 billion years ago, this area was hundreds of feet underwater in a Precambrian sea. The rock I'm standing upon, and which the St. Louis River is flowing down, is a kind of rock called slate. Slate is not the only rock that can be found in Cooke, but it is the most prevalent and most dominant rock in the area. In fact, Cooke State Park is located upon a geological area called the Thomson Formation, so named because of the town only 2 miles away from here called Thomson. This is a closer view of what slate looks like. It has a special characteristic called cleavage planes. You can see them actually right here. The special thing about cleavage planes is if I were to actually be able to break this rock, it would break along these planes in sheets. Unfortunately, there's no sheets around here for me to show you, but if you can imagine being able to simply peel this off, you would have one big layer. That is called slaty cleavage. As I mentioned earlier, this area was once hundreds of feet underwater, so how did all this rock get here? Well, there's a pretty easy explanation for that. Imagine this beaker of water is actually the deep waters of a Precambrian sea. On the surface, wave action keeps the water constantly in motion, but at the bottom of the water is calm and quiet, perfect for slate formation. Now, I'm going to add to the sea some fine-grained rock sediment, clay in this case. It will remain suspended in the water for a period of time, but eventually it starts to sink down to the bottom. Over thousands and millions of years, these layers of sediment build up. Each new layer puts pressure and eventually heat from the earth on each preceding layer. When enough pressure and heat is applied, the sediment layers become hardened into a new substance, a rock called shale. If the shale is buried even farther down, it hardens further, which is called metamorphosis. It changes from a brittle shale to a hard slate. From this demonstration, you should now be able to understand how this eventually becomes this.